next webinar will take place then in the US time zone. So, but I will announce then the date in the forum again. Yeah. Then some other organizational things. Here with the Saba client, we have different options how we can interact each other. So all participants are muted per default. I can explicitly set them to unmute. And there are two options here. You have this hand symbol, this checkmark symbol, and this cross symbol. So if you would like to ask a question, then raise your hand. I will see it here on the participants list, and then I can unmute that you can ask your question. So here we can make a small vote. We simply can check it. Can everyone see my screen? Then press the green check mark. If yes, if you don't see my screen, press an X. Okay, Sergey, Thomas, Wolfgang. Okay, Thomas saw my screen. That's a bit strange. But okay, it seems that it works. And also Wolfgang here. He cannot see my screen maybe. Or he can't hear me. Can everybody hear me? Let's try it this way. Use the vote symbols here. I don't see it for Sergey, I don't see it for Thomas Jenic, I don't see it for Wolfgang. Mate, Wolfgang can't hear me. Okay. But now let's start here with the current with the actual webinar. I prepared three sessions. As I announced in the forum, I will cover some basic things as well as some expert or advanced things. And today I would like to start or to give you a tech tip here, how you can work with the simulation task environment in NXCAM. So we introduced it with NX 1202. And I saw when I'm in contact with customers or partners, I see that they heavily struggle with the entire workflow and they switch back and forth between the task environment, and which is not required. So therefore, I decided to cover this topic today, that I can show you how you work efficiently with the task environment in NXCAM. The next thing is more an advanced topic. Especially for people who doing CSE customization. I'm very often get questions or the same questions about the Cycle 800 customization. For example, the tooltip is on the wrong position after the axis rotates, or I'm getting an alarm message, and there I have an FAQ started here and give you some tips and tricks how you can solve your problems for the Cycle 800 customization. And the third thing, it depends a bit on how fast we can go through this first two topics. I would like to show you the capability how you can exchange very simple complete machine environments or a machine kit in your NXCAM environment. So it's as I mentioned, it's grayed out. Maybe have the time for it, or maybe don't have it. And at the end, I would like to invite you that you post here your questions or your topics where we would like to where you would like to discuss here in that round, or where I can give you an answer. I will reserve about 10 minutes for that. Or 5 minutes. 5 minutes. No, let's make 10 minutes. So if there are no questions, I can cover then the third topic here. Okay, let's start. So we already has this. Yeah, if you have any questions during my presentation or during my demos here, please raise your hand. I hope I will stop then, or simply add a question to the chat window, and I try to answer then as fast as possible, either at the end of the session or during the session. But don't hesitate to use these options here in this webinar client. Okay, let's start with the first thing. Or before we start with them, are there any questions for that? Let me look here into the participants list. Are there any open questions? If so, please use the raise hand symbol or use, yeah, cool, use the vote options. Sure, use the, that's also fine by me. I see we're getting more and more people here. Nice, cool. So let me start with the task environment. Here we are. So you should know CMyNX. Before I start directly in the CAM session, I would like to show you another thing, what is really helpful and what I really like. We introduced it, I guess, with 1847 or with NX 1202. 1202 it was. We have here in the ribbon, so when you start your NX session the first time and you have the CAM license, you have here on the left-hand side and palette option where you have all the available machines in your NX installation, which you can select here. So you can now simply select one of these existing machines to start your CAM setup with your machine. For sure, you can also customize this. Therefore, you have to go to the Mach templates and CAM machine samples. There is a PAX file. You simply can remove the existing ones if you like, or enhance the existing file here with your own machines or the customer machines. So for sure, you can also create your own palette, that's up to you, but there is an existing option, and I really like this. So you don't have to take care about where is my machine installed, where is my CAM setup. Simply select one of these existing machines. Today I will take the SIM07 machine. Simply click it, and if you load options correctly, then you can start very fast your CAM setup, including the machine. Okay, first, now let's have a focus on when we would like to simulate a machine. So in the past, we had the option prior to 1202, I guess, that you have to select here the external file simulation with menu, tools, and then external file simulation, or you had here the two-path based simulation and the simulate machine. So at the end, we decided to have one entry point to simulate a machine. So the first thing, if you have nothing selected in the ONT, you get a message that the selected simulation type requires selection of operations or program group. That's no error message, that's only an informational thing. Simply press OK. Now you may get confused here that it's grayed out. Why is it grayed out? You have nothing selected, where you can start the simulation. So when you have selected now a group or an operation, you have the options two-path based simulation, machine code based simulation, or even the external program simulation. If nothing is selected, you can only select the external program simulation, where you can add or simulate an external file. Okay, so let's first start with the machine code based simulation. So the entire environment here is now focused on doing simulation stuff. So let's start with the ribbon menu at the top here. On the left hand side, you see now the simulation time. It's not the post-processed simulation time, it's the pure simulation time. So when you execute now the simulation for that and press play, you see the time running for this program group. And when we finish that, you have the time displayed here on the top. Now it takes 5 minutes machining. It's the machining time at the end. So then we have here our selection type for the simulation. Then we have our VCR buttons. We can step backward, we can step forward into into a subprogram, or over a subprogram, or out of a subprogram. So for example, let's take a look at the tool change. Here we have an M6. Let's make a breakpoint in it. I press play. And now when I select the step in button, I jump into the subprogram and can step through it. If I would like to directly jump out of the subprogram, I select here step out. And it simulates now till the upper level is reached. So if I would like to step over an subprogram, I select the option step over, and now it jumps over the subprogram call. Very simple. So then I have the stop button for sure. I have the reset machine button where I can reset the machine. And here I can define my simulation speed. So many people requested that we bring back the slider option back. It will come with the next release version. This is what I can tell you today. Then we have here the options where we can simply activate or deactivate the collision options we have. So I can simply select here machine collisions. Now the machine collisions are activated. I can activate the tool and part collision detection. The tool IPW collision is not activated, it's gray out because material removal is currently not activated. So when it's activated, you see the IPW and can now switch on the tool IPW collision check. So, and I can simulate now my environment here. I can stop, and during the simulation I can simply switch them on and off, as well as the material removal, and for sure switch it back on. I can do this very easily during my simulation, but let me deactivate it here for this demo. The next thing is, if you are not interested in to have the NC code, you only would like to have here the simulation. You would like to see how the tool is moving, belongs to part. It's fully fine. You can undisplay the NC code. So the execution of the NC code is displayed in the so-called execution view. This is your current view of the simulation. You see, let's start here. You have here the state attributes. This is in the background. There is the CSE setting where you can set different state attributes. You can customize it by your own if you like. You can display here any states of the simulation. Then we have our NC program window where we display the NC program, and we also have a search option for that. So simply press Control and F. Then you have a search field in here, and also an replace option. In the background is a built-in ACE editor, so you have the full capability of this ACE editor, and this is one hotkey what you can use. Also the Control C, Control V, and Control X, all the common shortcuts are working in this editor field here. And for sure, you can also edit here something, but not in the machine code based simulation. So we don't allow that you can modify the post-processed NC code. This is per default. So If you would like to customize this NC code, you have to switch to the external file simulation. I will show it later today, but this is why we don't allow this here in the machine code-based simulation. Let me finish here the ribbon menu. Oh no, not the ribbon menu. Let's go through here the execution view. Sorry. When you start here the first time the machine code simulation, so you see here at the bottom a small field that you can enter here number of lines of the NC code. So we decided for performance reasons, that we don't post all the million lines we have, so that we only post the first 100 or 200 lines. There's a customer default for it. So, and if you would like to post everything up front, simply the default here is all. Simply press this button here. Or when you say, okay, you would like to have the next 150 lines, simply add here a number, press post-process, and the next lines of your number getting post-processed. So if you would like to have everything, simply delete the number and press play, and now also the display here gets removed. And everything is post-processed till the end. So the next thing here is the call stack. When we here look at the, where is it? The M6. Let's go back to that and make a step in. You see here now we are on the call stack, we are on the tool change level now, and we can here with a double click switch back and forth between the main level where we are currently and the tool change. It's only a display option. The next thing are the variables. Oops, there's something from older things inside. So we can add here variables. You can add any NC variable you would like to have to see. Let's, for example, look at the R variable. It's 0. Let's take the, let's make it that way. Let me enter here 100 millimeters, for example. I jump over it. Now the variable gets this value of 100. I also can add here this to the variable section inside. I can also do some math here, or can add any expression I like. Another possibility is to show values of variables or expressions. When you mark it, you simply see on the tooltip now the value of this variable. It's very helpful. And for all people who are doing CSE customization, we also can add here some expressions or some CSE functions, for example, to get variable function. So I simply can add it into this field here and get the value from this function or any other function. You can also do combinations of different functions. And last but not least, the machining time analysis. Here you have a good overview about the current machining times, the cutting time and the secondary time, and the child times of the secondary times. You have a very good overview. You can also set in start clock and in stop clock or in reset clock. So good so far for the execution view. Let's have a look on the program manager. Let me delete this here. This was my preparation. Yeah, the execution view, as the name is for this dialog, we see the execution. It is for the execution of the NC code. The program manager, it's a manager. Here you have a good overview about all relevant files or programs to your session. So the parent or the main node here is our machine. Then we have an external source. This is our placeholder where we can add external files. or external NC code. I will show you later how we can use this. In the post-processor node, we see here our post-processed NC code, and also have here again the option for the post-processing. Then we have our CAM setup node. Here we see all relevant files related to our CAM setup. And when I do a double mouse click on that CAM setup here, you see here you get an overview on the right side where this node, where the folder is on your disk when you add here files in it. So I would like to see where is my 2INI file located. Simply make a double click on the parent node here of this program, and you see the file path where it is located. Because many people are struggling where the file's coming from, and this is very easy to find it out with that. And also for the INI programs, currently there are nothing in, but here for the subprograms you see the 2INI file is created and located here. Then we have the machine node. You see all relevant files which are related to the machine. We have our INI programs. You also make a double click on the parent node of this file here. First, you see the content of this file when you make a double click on it, and in its parent node, you see the file path where it is located. And the same for the subprograms, and the same for the Züg archive. I will not go into details what it is. I will talk about later in other webinars. Okay, what you also can do is you can simply modify something in here. If you would like to make a comment in here, let's make it here. Let's make a comment, my comment, for example. I do it here in the tool change, and you see it gets here the asterisk that there is something modified. I close it, and when I now start the simulation, open the execution view, jump into my tool change, I see here my comment. So Program Manager and the execution view are always in sync. So which means you can see I simply can add here other things, my comment 2, and you see here it will also display it in the execution view and gets directly executed here, or when the execution cursor jumps over it. So therefore, my suggestion is use the Program Manager up front when you do some, when you prepare your environment, and during the execution, you can also use here the execution view. And as you can see here, when I add something in the execution view, it is also displayed in the Program Manager. Very easy. So the Program Manager has a bit more functionality as to display all relevant files and to edit some files. We also have here in this information group the capability to see which breakpoints are active currently. You remember I added a breakpoint in this line for the M6 here, and the program and here in the information section it simply displays me where it is. So I also can add here conditional breakpoints. For example, I would like to stop the simulation here on the trafo off. So without explicitly setting here a breakpoint, let me close this. Let's make a reset and press play. And now the simulation stops at this command here. So, and simply you can also deactivate it if you would not like to delete it, but you also can delete it. And another very helpful thing is search functionality. If you would like to search for an M6, simply add this here, press the search button or press enter, and you get directly all search results where the M6, for example, is in. And when you make a double click on the search result, you directly jump to this position in your NC code. Very helpful and really powerful. But let's not focus here on that. That's about the Program Manager. Let's talk about the machine status we have. Let's remove this. Here you can have an overview about all axes which are attached to the current channel. So if you have multiple channels, you see all the channels available and which axes are assigned to these channels. And you can also move it here with the sliders to left and right, and so as you already know, you can move them here in this way. We also have an advanced axis option. There we see more information about the positions in the current work coordinate system or the machine coordinate system, the remaining positions or the remaining values to the position, and so on. Very helpful. So we also have an overview about the tools. When a tool is loaded here in the spindle, we get the length, we get the radius, the active correction, the name, and where it is mounted. We also can have here look at the velocity profile, so we see how the axes are moving when we execute the NC code. There you have a good overview if you have a smooth corner movements or not. So here it's really sharp edges, and you could imagine the real machine will then also move in that way. Or or maybe you have not set up correctly your machine simulation with the real machine datums. Then when you add them, you see we get smooth axes here, smooth edges, and you can look here at the different channels for sure. Good. So good so far. Machine components. Oh, sorry, it's on the other screen. You simply can display or undisplay very fast different components. And if there are collisions, unfortunately I don't have any collision here now, you can, if there is a collision, you simply press here show colliding components. Everything gets deactivated except the colliding objects, so that you can very easy and fast can display the colliding components. So for all of them who doing CSD customization, here you have the option to start a machine configurator. I will not go into the details. Then we have the simulation settings. Here you can set all relevant settings to your simulation environment. I will not go into the details more. You can also save these settings and load different settings, and you can also set here very easy the tool path and the tool trace. So that's it for the ribbon here. Now I will talk a bit how you can handle NC programs very easy. So currently I showed you that we are in the machine code based simulation. So in the past, when you started external program simulation, you were prompted to this dialog that you now select an external file from the disk from somewhere else, here hello for example, and then it gets loaded. That's the old approach, still valid, but from my point of view, not very efficient. Simply go to the program manager, go to the post-process node, post-process everything, simply mark them all, copy them, and create a new here in the external program. I call it webinar MPF, and simply paste it in here. And now simply switch here to external program simulation. And this program gets loaded, and as you can see, the node here is away that it's not editable, and now you can edit as much as you like. You can also add here an 66 if you like, or whatever it is. So that's the way how you can simply switch back and forth the internal and the external program simulation. So you may recognize that here is an asterisk on it. So now when you press save, it's saved in sense of your program manager environment. So, and the next capability what we introduced, I guess also with 12.02, when you save your part file, I do it now. I have no write access. Let me simply do this here. Noch samples and C simulation samples and the sim07. I have to clear the read-only flag. I simply save it. Now it gets saved, and when I close my NX session and, for example, send my colleague here this part file, that he look into it, he opens his NX session. And when he now opens his this part file, press simulate machine. And now when I directly start here external program simulation, the program is here. What we added here in the program manager before. That's very helpful. So yeah, that's it so far for the simulation task environment. Are there any questions for that? So let me open here the overview. Please, if you have questions, raise your hands. If not, then leave it as it is. I will jump then to the second topic for today. Okay, then let me talk about the session FAQ ISNV cycle 800. So many people having problems, or not many people, but there are very often people who struggle with the cycle 800 when they commission that with in their simulation environment. So here is exemplarily a question. Unfortunately, the CSE for cycle 800 doesn't work at all. The position of the tool is not correct after rotation. So everyone who set up in cycle 800 in the past knows this, and maybe has had also this problem. So today I would like to show you some tips and tricks how you can check different areas that you can overcome this problem. And also another thing is I get an alarm message, alarm 604 blah blah blah. What should I do? But I will talk about later this. Yeah, the first and the important thing is before you look into any cycle 800 settings, you have to ensure that your basic offsets are working, which means that you can move to the machine zero position correctly, that the two length compensation is correct, and maybe that your local offset is correct. So how can you simply test it? So let me check this, take this machine. How can you simply check if the machine zero position is correct? Simply type in G53 or the controller relevant command and move to this position. For sure, nothing moved because the machine zero position is here within the spindle. So there's one important thing you need to, or one important rule you need to follow, that when all axes are zero, all axis values are zero, the tool tip, the tool mounting junction must match the machine zero junction. So if this is not the case, for example, the machine is assembled in this And this way here, you have to move, not you have to move. So if the machine 0 position is here, maybe in the middle of the table, you have to tell the system the offset between the assembled position here from the tool mount to this position on the table. And this is the setting within the initial values here. Here you tell it what's the offset between your tool mount position and the machine 0 position. We make it very simple in our out-of-the-box examples. We very often simply add here the machine 0 into the spindle. So therefore all axes are in 0 position and we don't need to add any initial values in here. Okay, let's go back here to our simulation. So when you then move to within G53 x0, y0, z0 to the position, so the axis should move to the machine 0 position. So if there is an tool mounted, so let me check shortly which tool is mounted, or which tool is created. It's here the T, this guy. Let me reuse this. Simply add the tool call here and add in D1. I will jump over, sorry. And as you maybe can see, the tool jumps here, or the axis compensate now the tool length here. Let me do it again, maybe it was a bit too fast. So tool gets mounted, and when I now move with the active tool length compensation to 0 position, it moves up. And the same is here for the G54. When we now move to our first local offset, I guess it is here at the top of the part, it should move in this position. So as long as these positions are not correct, you don't have to take care about any problems with the Cycle 800. So this is the most important thing. And another remark is a good check is always, do you have the same behavior when you execute these lines here, then doing in Cycle 800 and doing then again the same lines. So this is also an indicator if there's something wrong in your Cycle 800 or in your settings in here. So another thing is you need to check if the correct chain is active. So I talked about the variable section here. In here you can also check some CSE variables. In this case it's the GVR swiveling chain name. So, and when you add this here in the section, you see which chain is active. So let's have a look here in our machine model, which chain is defined. You see here on the right hand side, or wherever you have placed your columns, that we have a chain defined B, Y, C, X, C. And if you would like to use now the Cycle 800 in your simulation, you can simply check by adding this name GVSDR swiveling chain name in this here. If you deal with different kinematic chains, how it is in the Sim09, let me shortly open this, Sim09. There I have different chains defined. On the one hand side the machine chain, and another chain for this adapter head here. So there's one important method in the machine configurator, or in the MCF defined. It's called GME getActiveChainName. Active chain name. Here it is. You see it is located in the MCF file, which means it's customized explicitly for the Sim09 machine. And here there will be passed one value, 1 or 2. If 1 is passed, it returns our chain. And if 2 is passed, then we activate the chain, including our adapter. So how can you now decide which number must be passed? This depends on the tool carrier dataset, which is loaded with your machine. You may be aware of the tcard def file where all the tool carrier values are defined. And here, this index inside defines you this value in here. So this chain name is relevant to this tool carrier dataset. And this chain name, number 2, as you can see here, is relevant to this adapter chain. So check this. So in case of the SIM07 machine here, where we only have one chain defined, let me open here the machine configurator. You will see that we simply return, come on. So it's not in the current file, it's located in the basic CCF. SDR, oops, SDR. Where is swiveling? Sorry, it's where it is. Not swiveling, sorry. Chain. I'm looking for this here. It's located in the basic CCF. And you see we simply return the SDR swiveling chain name, what I added here in the CC variable section. Yeah. Another important thing is you need to check your rotary axis directions. So you have defined here your machine 0 position with their direction of the coordinate axis. You see it here. So X is to the back, Y to the left, Z to the up. And for sure the rotary axis now, depending on the setting what you did here in the machine 0 position, which means the A-axis, the positive A-axis direction is clockwise around X. The positive Z-axis direction for the rotary is now clockwise around, counterclockwise around the Z, and the same here for the Y-axis. So how can you simply check this? Go to the preview motion. You get here this dialog where you can move all the axes here. Where's the Z-axis? And you also can check now the rotary axis. So there's one important thing, move spindle about part. So the settings for the rotary axis directions are always from the part side. So which means we have defined here our, when I would like to check now the B-axis rotation, I take my right hand now, look at my thumb where it looks. Now my thumb looks in the same direction as the Y-axis, and the fingers showing my positive direction of this axis now. And in that direction, the rotary axis should rotate. And as you can see, when it rotates positive, it rotates around the Y-axis. Simply take your right hand. Your thumb looks in the same direction as the coordinate axis, and your fingers showing the direction of the rotary axis. So how it is for the, so this is now a tool axis. So for part axis, so let me move in that way. It moves not in the same way as here from as this axis. It's differently. So when we look at the same rule, take the right hand, the thumb goes to the top, and our fingers showing the rotary direction. It's differently. It's the inverse direction. We can say it's wrong. It's not wrong because we have to look from the part side. So you can check this, simply switch this on here. And when we now look from the part side, you see the machine or the axis rotates in that way. And this is how we set up rotary axes in our kinematic model and in the machine datums. When I look here at the z-axis now, where you also can check it, here it rotates the inverse direction because it's in part axis. So we always have to look at if it's in tool axis or if it's in part rotary axis. And do your settings in that way as I described it here. So part axis always have the reverse direction, and tool axis have the actual direction of your coordinate axis or around the coordinate axis. That's very important to know. So you also can see this here in our machine settings in the tool carrier data set. So we have in here our vectors from the rotary axis. You see here our first axis is the B. That's our tool axis here. It is here. 0, 0, 1, 0. It's positive. And here our table axis, which rotates the part, is a -1 on your z-axis. Because of you have to look at the part rotation. And this is how you easily can check this. Another thing is, I have to hurry up a bit, sorry. You have here this transformation stack. And there is one important transformation. It's called $tool. It's always available and always present. And if it's in here, maybe it's on the wrong position. So because $tool must be either at the top of the stack or at the bottom of the stack. It depends on which machine configuration you have. So, but simply look into the transformations and look where $tool is placed here. So these are only some small helpful things where you can set up your Cycle 800 hopefully correctly. So the second question was where we are here. Where is my PowerPoint? The second question very often is I get an alarm message. So simply go to the website from Siemens MC. Come on. And simply add here the alarm number. I guess this is a very common alarm number. And then you get here the search result for the alarm manual, the diagnostic manual, and can read through the alarm message. So simply open this and open this. You have to add it here again. And here, when you click on this, you get a message about what the alarm number is. Okay. And if you checked, when you have checked the manual about the problem, you have to look at your machine settings. Go to the program manager. Either it is in your tool carrier data set, maybe the tool type is wrong, or the tool carrier name is wrong, or the axis names are wrong, or some setups here in the machine datums. So if you use the real machine variables, then take a look on it if they are right or wrong. Also check your machine INI file if you load something in here which setups the machine. So this will help in many cases. Okay, so good so far. Let me open again here this window. Are there any questions so far? So I will skip the third topic to the next webinar session. Are there any questions? So, if so, please use the raise hand symbol here. You should have the same one. And then I can unmute you or add your question here to the chat window, please. Come on. A simple question. Only one. Okay, then I have David has a question. Okay. I enable you. So David, you should now be able to speak. You have to switch it on your side. Yeah, I can hear you perfectly. I guess, or I hope it is in the NX help described which type of variables you can enter in the variable section. I'm not sure. So you mean, so did we talk about the same? You mean what I can enter here? Yeah. So the simple thing is you can enter whatever you like here on numbers. So you can also add the variables from the machine configurator in here. All what you have here in internal variables, you can simply add them. And you can add also some methods which returning a value. For example, if you have here a method defined in your machine configurator, you can simply add that. And when this method returns a value, it will be displayed. And as you can see here, I can also, for those who are familiar with CC customization, I can add here a complete expression of different CSE functions and can get the values. But it depends on which variables, or you can add here NC variables. But there it depends on how the machine is set up. Hope that answers your question, David. Yeah? Okay. So any other questions? Alexander, applause. Thank you. So this is my last question, or my last questions. Do you like this format? Was it helpful? Was it informational for you? Should I move on with exactly this type of format? So please use the green check mark or the X. There's another question from Johan. Okay. Johan, my question is, first thanks for this voting here. Johan, my question is about which controller. It's numeric. Okay, sorry. What do you mean with it cannot interpret? Or let me unmute you. Maybe it's helpful, Johan. Here. Enable you the microphone. So Johan, you should now be able to speak up here when you unmute your phone manually, if you like. So the G48, it's in tapping cycle. It should, or do you mean the cycle 84? Because in G84 itself is an G command itself, but it is not in cycle. It's in cycle in Fanuc world. Or maybe I'm not aware of this cycle G48, 84. Sorry. Ah, it's a very old cycle. Okay, okay, understand. Yeah, I mean, you can follow the approach as we do it for the Fanuc, for sure. You can simply let me show it. You can simply uh, add, for example, here in your machine configurator an G command. Where it is? Ah, not addresses. G command G48. And what you can do is here you can upsala, not 48, 84. So out of the box, my answer is out of the box. It's not available, but you can define your own G command. Define it here. Doesn't matter in which in which group it is. Ah, it's a Sim09, so let me show it in the Sim07. Sorry. So in the current file, G command G84, simply add it here, and then you can say call a subprogram and simply add this Sim07 CZ driver Cinemeric subproc. Go to this position here and simply create a you have to create it for sure. New cycle 80 G84 cycle.spf. Yes. Switch to SPF and here simply make this. Save this. Ah, it's still on read only. I save this. So when you now execute here in G48, I have in G48, I have in step over, sorry. I also have to add it here to the program manager. So hello cycle. And when I jump into it, we have here our cycle. So I don't have the cycle code, so that's up to you where you get it. But you simply can add a G command in your machine configurator and go to call program and call a subprogram what you have created in your machine folder. Hope that helps. Ah, cycle. Okay, but cycle 84 is included in the cycle files here, in here. You can't see it because we are not allowed to ship them as plain text. But you can, there is one sample available. It's the Simo8. There's one, is it in here? No, it is, let me show it. When you go to Mach, Samples and C simulation samples, Demo Cinemeric cycles. In here is a part file and an MPF file. This MPF file shows explicitly the cycles, or you can use this to look which cycles can be simulated now. For sure, there are not all cycles from Cinemeric World in here, but it's only a small subset. And if you would like shortly check if it works or not, then yeah, and as you can see here, it's cycle 84. You can simply check if it's in here or not. Frank, you can't hear me? Can anybody hear me? Okay. Okay. Maybe there's something wrong, Frank. with your microphone, with your headphones. Sorry. Okay, Johan, have I answered your question? Please give me a green or a green check mark or a red cross. If not, you can also place this question. Okay, cool. If not, you can also place this question to the forum. Thank you. Alexander, is it possible to simulate that cycle without the 2INI file? Yes. Within our INI file here, what we have here, there are no cycle settings. I have to be precise here. There are no cycle settings in here. But there's one important thing. There are information about the tool which the cycle maybe reuses. So the cycle looks, for example, at the tool type. So if you have the wrong tool type, if you would like to make a drilling cycle, but you have a turning tool loaded, then the cycle fails. What you can do in this case is we have a CSE command called get tool parameter. Get tool parameter, and there you get the type. Where is it? Or was it get tool type? I have to figure it out where it is. Get tool parameter. I thought it is here the type in. Here. Yeah. Here is type as parameter. So when we look here, for example, let me copy this line. Start the simulation. Sorry that I'm a bit over time, but I would like to finish that. So we have the tool name. So our tool name is this guy here. When I edit, now I use the capability here to add CC functions. It was type. I'm not sure if it was uppercase or lowercase. And you can see the tool type of our UGT 0202 is milling. I mean, what you do then later with that is up to you. With this information, you have to set on another place then explicitly for the cycles the UGT. Where is it? 2NI. No, here. With this information, you have to set explicitly now this machine datum, or this NC variable to 121, for example, or 120. But this is then up to you if you don't use the 2INI file. So, okay, the angle of the tool. This is currently not part of the tool parameter function. So then you have to work with the 2INI file. If you have this enhancement request, yeah, talk to GTEC and create there an ER for it. Then it goes to the product management, and we talk about this. Okay, guys. Is there one more question? If not, I will close this webinar for today. I will let me wait a few minutes, a few seconds. Thanks for the hands here, for the applause. Very nice. Okay, guys. Then I wish you a very nice weekend, and I say very thankful. I'm very thankful that you joined it here. Hopefully we are a bit more the next day. Maybe others have had problems here with the installation because I had over 60 registrations. Yeah, then take care, and I will provide everything in the forum. I will upload a video there. I recorded it separately. And yeah, take care and have a nice day. Thank you.